All right, pressing on in section 12.2 on simplifying expressions. We'll work through the next four questions here in problem number one. This is parts G through J. So in G, we see x minus 3 divided by the product of x plus 3 and x minus 3. Okay, so as we were saying in the last video, right, we want everything in factored form first before we start dividing out and simplifying. So down in the denominator, I have a product between those two binomials. And upstairs, I have an x minus 3, which is really just the x minus 3 itself, right? And since the x minus 3 is common up here as well as down here, I then can divide those out, and that's going to leave us with a 1 in the numerator. And then in the denominator, I have that x plus 3 term. Okay. Now again, it's fine if you want to leave the parentheses on that x plus 3, but it's really not necessary. X plus 3 in parentheses is just that expression x plus 3 itself. So that is also a perfectly fine way to write it. All right, cool. And now how about h? Well, here, right, now I do not have everything in factored form. This numerator can be factored down a little bit. So we'll start by factoring out the x, and that's going to leave us with a 1 plus an x. And then in the denominator, I have an x plus 1. And for emphasis here, I'm going to put that entire expression in parentheses, right? I'm thinking about this entire expression as a factor. And now notice on top I have a 1 plus x, and on bottom I have an x plus 1. So although they look visually different, right, I can add in either order and I'm going to get the same result, right? 1 plus 5 and 5 plus 1 both equal 6. So in fact, this numerator, I'll go ahead and just rewrite it as x plus 1, and then I'm leaving the denominator alone. And now written that way, the common factor of x plus 1 is going to cancel out. And now what I'm left with is an x times 1, which is just x in the numerator, and then I'm left with a 1 in the denominator. Okay, now x divided by 1, of course, is just x. So I'm going to write the final answer as just x. But something to really emphasize there is that when you do that division, okay, a lot of times people just say that they cancel out, right? Well, they're canceling here through division. So the thing left over is a 1, right? When you cancel through subtraction, you're left with a 0. But with division, there is something left over there in the denominator, and that is a 1 in this case, okay? So our final answer there, which is bx. Cool, all right, so then pressing on, let's look at I. Notice in the numerator, I have that difference of squares pattern. It's x squared minus 2 squared, so it'll factor as x minus 2 and x plus 2. In the denominator, I have a trinomial with no common factors across all three terms. So for that, I'm going to factor it as a product of two binomials. Now to build the x squared, I'm going to need an x and an x. And for the 2, well, fortunately, there's just really one option, right? Two numbers that multiply to give me 2 would just be a 1 and a 2. And by making both of these positives, I'm going to get that correct middle term of 3, right? You can check easily by just multiplying. You're going to get a 2x and then plus an x. There's your 3x. All right, cool. So that's the rational expression in factored form. And now we can go ahead and start dividing out the common factors, which in this case, the common factor is x plus 2. All right, cool. So then we're left with an x minus a 2 and an x plus 1. All right. And again, I'll just write it in both of those forms. Both are perfectly fine. Moving on then to the last one in this row, we got problem J. Now, this is really a kind of a nice review of just factoring like we were doing in 12.0. So I have two trinomials now, right? One in the numerator and in the denominator. So for the numerator, I'm going to go ahead and factor that as a product of two binomials. So I got a x and an x for the x squared. And then for 5, well, I'm going to really only be left with one option. It's going to be a 1 and a 5. But now, see, since this is a negative 5, I know these signs are going to have to be opposite one another, and I need a middle term of a positive 4. Okay, so that would tell me make the 5 a positive, because I'll get a positive 5x, and then make the 1 a negative, because that's going to take 1x away for the middle term, leaving you with that 4x. All right, now down in the denominator, it's another trinomial. We'll factor this way. So we got an x and an x. Again, fortunately with a 1, there's just one option there, a 1 and a 1. Okay, and then finally to get that middle term here of a negative 2, right, that's going to imply that both of these are negatives, right? So their product is still a positive 1, but now I'll get a negative x minus an x. That's how that negative 2x will be built. All right, and then a common factor there of x minus 1 that will divide out, and there we have it. We're going to get an x plus 5 over an x minus 1. All right, great. That's going to do it for this video.